Welcome back to our Python class, and we will look at Python modules and packages in a way how to do modular programming. In fact, we already know a little bit of how to separate your tasks using functions, right? That's already the first step towards modular programming, but of course also using classes, right? You have a class as blueprint and then you have objects from those classes. Well, modules and packages is going one step further, bringing you, well, greater modularity, I guess. Well, let's take a look actually at some of the advantages. Why would you want to do this, right? So let's let our AI friend show us some advantages here. It's kind of funny. I tried playing around with this, right? So code reusability. What else? Code readability. Okay. Code maintainability. Okay. Code debuggability. Okay. Testability. And I think we are getting the idea. Are we going to repeat ourselves at some point? No. AI is just getting started, but I would say it's maybe a little bit of overkill right now, right? Extensibility, right? These are all true things actually, but they of course refer to, well, we got modularity, modular programming, code modularity, of course, right? Simplicity, again, debatable, right? But let's get to up to 20, see if we have actually usability, right? Consistency, elegance, well, again, debatable, robustness, and maintainability. There we go again. So AI of course gets starts going in loops. Okay, so but the main things are simplicity. Well, idea is that, again, do we have simplicity? The main one is somewhere here. There it goes. So this means we focus on one thing, right, at a time. Like if you need to download something from the internet, right, you have a module for that. If you need to parse your web page, you have a module for that. You need to have a database connection for a specific database, you focus on that, right? So you divide and conquer again. So focus on one thing at a time, right? And let's see what else. Maintainability, do we have that? Yes, we do, right? So meaning easier to fix bugs, yeah, of course, right? And also less interdependencies, right? Meaning less dependency on each other, on other modules, right? So you have it, you keep things again, modular again. So reusability, we have reusability here, yeah, of course, that's the main one of the main ones, right? Is other, yeah, you can use the same code in multiple places, multiple applications, right? So very good. And what else can we do? Scope. We don't have scope here actually, but scoping, right? So code scope, right, is basically, right, avoid of course, name collisions. Again, naming things are hard, right? So those are the main things again. So why would you want to separate your code and separate modules? Well, the good news is, okay, this is all theory, right? All good. How does it work in practice? In Python makes modular programming extremely easy. Probably the easiest language I've seen. You basically, especially these days, you basically just write as many modules as you want. And what's the module? It's just another Python file, right? On the simplest level, right? So let's get started. Let's write a simple module and implement it in another Python file, another program. So let's have this is my main program, right? In fact, we've been using modules before, right? We've been using, for example, system, right? OS, for example, right? We've been using some of these, for example, in strings, import, or datetime, right? We've been using that. In fact, later on in the class, we'll go over through some of the popular standard library modules. But let's make a new one. We don't have one, right? But let's do it, right? It's called clarity. Do you have clarity here? Yes, sure, why not? Right? Why not? Let's add one more. Okay, but let's make a module. Again, I'll close this. I'll close the picture of the nice spaceship on a space module on here, right? And I will have this module. It's basically a Python file. I'll have some data, some variables, text, my list, and a pie definition. Maybe also have a add function, you know, very simple, right? I could have my own storage function. Let's not do that. Let's do an empty class. Why not? Right, I have an empty garage, for example. We already have this, remember? Or right, so now I will also add this little line, print running my module. So now, if I run this separately as a standalone program for now, well, running my mod, because what happens is, of course, I had these, you know, I imported some of these, I started using my variables, but basically I run through all of these code and I printed, you know, I run this text, right? And there's nothing else for now, right? I just run a single instruction. But okay, so how will it work if we do it from here? So basically, as long as we are in the same folder, I can do import my mod. So import my mod, that's the name of the file. So my mod by, yeah, right, must be in the same directory, right? And let's run it. So if I import it, what will happen? Notice, running my mod, it actually ran the whole code, right? So I can start using it already. So what do I mean by start using it? This means I can already do something like this, right? Import my mod, I can do my mod, you know, I could add, you know, 2 numbers, you know, right? This is a function from my mod by adding I am 3 and 8, and of course I could have also saved the result, right? This returns a plus b, so I could have saved the result. Why not? Save the result, right, equals, you know, and I can print result. Of course, which has nothing to do with my mod, I already saved it, right? So this would work as well. All right, 11. So I can also print my mod. What do I have there? By, let's see, I have garage, my list, or I have my, what do I have? What else do I have? I'm using dot notation. I have pi. What else do I have? My mod. I have text maybe, and I have my mod list mlist, right? So notice the dot notation, right? Kind of similar to class-based notation, right? We used in our objects, right? But so yeah, so I printed my quick brown fox, my list, and my pi. I have my pi as well. Okay, so it's great, and I can make my own class, right? I can make a class. I can make my own new garage. You know, new garage equals what? Yeah, in fact, I have my AI assistant suggesting this, right? So class from my, you know, create object, create new object using class from my mod. Okay, and of course, then I have, you know, I don't think I have anything there. Let's see, do I have anything there? New garage dot, oh, I have my name basically, right? Nothing else there, right? Right, so garage initialized, self name is la biblioteca, and I actually print the property. And again, where did it all come from? It comes from the other file, right here, right? So I have my blueprint here, and I actually made it. So now, this is all good. Actually, of course, the best practice again should be, I should say that this module is kind of ugly because I have everything. In reality, classes would be in a separate module file, you know, one for each class, for example, right? Big class especially, right? Maybe some simpler class, we have same class, right? Typical is to name it, you know, as the name of the class, you know, like garage would be the garage.py file, for example, right? So, okay, so I hope you got the idea how it works. Basically, when I do this import, this runs through all of the code available. If you have any instructions like running my mod, right, it will print. This actually might not be, usually you might want to avoid this, right? Because you generally want to only import things which don't do anything. Generally you want your import to do nothing but import, right? No, you know, no printing, no nothing, right? It's rare that you want to do something else. So basically, so yeah, so let's do that. In fact, that's why we want to do this, is to actually have the file, well, have a dual use, right? Maybe you want to run this as a program, right? So, but let's show you how very typically how it's done. In fact, that's the main way of how you'd separate your modules from regular files. Well, you do something like this. If name, you put an if statement, right? So this if name is a special variable, basically you check whether it is a main program, right? So this is be typically the place where you will put some tests, or maybe you have your main program here, right? But this is what you do when it runs normally, right? So let's do something else here. So I'll comment this out. We don't really want this. Let's run it like this, like a main file. Notice this runs normally. I made my garage, right? My car, right? Garage, right? So this is normal file, ending normal run, ending, print, ending normal run my mod, right? Okay. So this is what we usually do. So notice something. So I run it again. Yeah, ending normal run. So because this I run it as my main I run my module as a main program, right? However, if I import it here, let's take a look. Let's take a closer look. Now I'm using my add. I'm using, of course, using my pipe, my text, everything from the module, making even using the blueprint, right? But notice what's not happening. I'm not getting anything out from any of this. Nothing's happening. No actions made by the modules, providing us with some data, some variables, also some functions, some classes, right? But it's not doing the work. So philosophically, you don't want your module to do any actual work. You just want it to. You want to be able to import it. So now, again, using this special if statement, you can have the best of the both worlds. You can import this module, right? And also you can put everything you want done as a regular program here, right? So you can put everything you want done in this special if statement. Yes, you could even do an else statement. This I rarely seen this done, right? And let's do this, right? Let's take a look. I can do this, right? I'm running it here. You see, it's normal run. This part here runs because I run it as a main file right here, right? However, if I import it, what will happen? Let's take a look. You see, I was imported. You see, this line here runs, this line here runs, right? Again, rarely would you want to do this. Again, you usually, the idea is not to do, so idea is to do nothing, right? So again, this is, I'm going to comment this out, right? But technically you could if you wanted to, right? But that's a place where you put, so again, so this is, if for example, you say, okay, my module it's okay, it's not really a standalone program. What you can do is here, you can put some tests here. Like, for example, you can check if your function works correctly, whether 2 and 3 is indeed, in fact, 5, whether add function works correctly. And you might say, okay, why would you want this silly example here? Well, these silly tests are actually important because maybe you're doing some advanced stuff in your function and you, well, forget about the basics. This will be sort of like a canary in a coal mine, right? It'll tell you if something is indeed wrong, right? So you can do a quick test of your module. Okay, so either you put your regular program here for module if you want it to run as a regular file, or you can put some tests if you don't really care about it being used as a main file, but maybe do some tests. And of course, again, you could just do nothing. Of course, you could, if you don't want any tests, well, you'd probably want some tests. You could just basically, ignore it. But main thing, don't do anything here. Like, don't do any even print, right? Don't do anything. You can have your variables, you can have your functions defined, but actually don't do processing here, right? If you want to do processing, put it in here, right? Do some any sort of program running. Okay, so that's a philosophical idea, right? And now again, let's run it again. And yes, indeed, my biblioteca, right? Everything runs. I'm using my module, everything, all the facilities provided by my mod, right? Pi. And again, these names are completely arbitrary, right? You can choose and make whatever you want. Of course, if you want, you can go to check your PEP naming condition, PEP 8, PEP 008 naming, right? And rules, style guide, remember, on what was it for imports? You can check your indentation, naming conventions, right? Lowercase, overriding principle, on single, right? Names to void, of course, on class names. Class name should be, remember, class name should be capitalized, right? Variable names, right? If you want something special, that's also small names, right, lowercase, right, and let's see if there anything about modules. Maybe there is something written about modules. Well, I guess not. Okay, but so now this is now we can make we can make our program as modular as we want. We have main program and we have separate parts. And again, one of the advantages is different people can work on different modules at the same time without causing any problems, for example, with your repository, right? If 3 people work on the same file, you'll have to spend some time using Git to resolve conflicts, right? So again, it promotes, modularity, of course. Okay, and notice again how using this my mod also provided what I was talking about scoping, right? Name collisions, because I'm importing my mod, so I can use everything dot, so I don't have any problems. I have no conflicts, so no conflicts with built-in with text or pi or mlist if we had them, in this file, right? So that's very important also, right? So also say my mod garage. Okay, but it is actually people like to use also there are other ways of importing, right? There's a couple other ways of importing. They do the same, well, effect is the same, except you have more control again, and maybe slightly slightly more ways to shoot yourself in the foot as well. So let's show you. So you can basically you can rename your module that you import, right? So import my m as mm. I'm going to close all of this here, right? I'm going to comment this out. So it will happen. Nothing will happen, I hope, right? Why did nothing happen? Because, well, I only imported, and right now I have my if guard here, right? So nothing happens, but I can immediately start using it. I can do this, add, of course, then. So basically all I did is I renamed it, and of course it will be so on, print pi, right? Again, dot works, you see, and so on, and so on, right? So that also is quite nice, right? Yeah. So basically renaming. Again, in Python, it's very common. It's very common. Popular external modules and packages. Right. We'll get to packages next. Like to use the short 2 or 3 letter aliases. Right. So again, so maybe somebody else using again. So of course. The danger is if you are using some bigger project and you have lots of imports, maybe, well, happens sometimes module names also may overlap, right? Maybe somebody else is using this name, so you need to rename it your own module. Okay, so that's one way. Also, and this can be sometimes very good practice, but there are some dangers. You can import some things separately, right? Something like this, right? So now I can do, right? So print, add, on print pi, right? So quick, so we can import only danger, yeah, right, with another module, right? So that's the danger. That's why this approach is very nice. It's like a laser. If you have a huge module, maybe you have like 100 functions here, right? You don't want to maybe import everything. So this is also alternative, right? You import only 2 things. You don't need all the 10 things you have or 7 things or whatever you have there, right? Okay, but then it happens you want this short way, but you also, well, you don't want to import everything, but you also have a problem with add. Maybe you have a local add function, right? So what do? Well, you do this. You import your specific function. So from my module, I'm going here, I have my function here. I'm going to import only add. By the way, this will tell you if I write it from my mod import, it should tell you pi. Well, actually that's my AI assistant, but even without assistant, even if you have Visual Studio Code or a good plugin, or maybe using also PyCharm, most good IDEs will tell you what you can import, because I'm saying, okay, I want to import from my mod, I want to import specific things. So in this case, I'm importing add, but I'm renaming. So now, of course, I can use this now. So now I can use this rename. Right. So my add, my add, 2 plus 7, right? And of course, it will work. Right. So this is the same thing. So this is a function called add in my modpy. Yeah. Okay. So that's also right. And the last thing, well, is there is also something using a wildcard, like a joker, basically, right? You can import everything individual, and this is something I don't really want you to use. Why? Because basically you are importing everything. Like you would import it, import add by, but you don't have a control, and you might import something you forget or might not notice, and it might cause a name collision and really hard to track down bug. Right? Maybe you have collision with especially if it's not your own module, even if it's your own module, maybe you have a renaming, maybe you have a variable text or something, right? And you imported everything, but there might be a name collision. So that's why I'm not even going to show you, but yeah, it is theoretically possible, but avoid this. It's just a use, again, most of the time, just importing directly will be the best practice, right? Maybe again you might want to rename it, or maybe you want to actually just have a couple specific imports. Okay, so this is all good, and this is actually already most of the work is already done. But let's take a look at something a little bit deeper. Let's go and actually import a package. So, well, what's a package? Well, you might be say, okay, what's a package? Basically, it's a folder with modules, right? Well, it's not completely strictly true, but for practical purposes, it is going to be enough, right? So you can basically organize your modules, right? So we'll make a subfolder. I'll call it my package, right? And then we'll have even maybe subfolders, right? And let's say I have my utilities. Okay, why not? And it has a utility add. Okay, very simple function, very similar to what we had before, right? So how do I get to this? Well, right, so again, notice my utilities. Well, actually, I don't even have my main guard, right? I could add a main guard, but it's okay. So what I do is I import this my utilities, right? And unfortunately, right, this means now unfortunately I have to use full pass. So I have to do something like this: my package, right, my utilities, right, and utility add, right. So I'm going one folder deeper. Right? I can't skip this my utilities at this moment, right? So that's unfortunately not really that great, right? It's possible, right? I mean, it's fine, right? It works, right? So, but I have to keep typing this. So I'll show you a little trick, right? We can do, well, let's go even deeper. I have also sub package, right? So it's like you have a package with extra packages, and I have sub utilities, something like this. Okay, I have a magic pi, right? I have three extra functions, right? Sub print, bad print, right? And well, okay. And let's import them, right? So I'm now importing this, right? And unfortunately, again, I still need to, right? So I imported sub utilities from sub package folder, right? Package folder, sub package folder from package, from package folder, right? So, and again, so I need to do this, right? So this will work, right? Something 23, right? So 1, 2, I have to, okay, so I have to say, okay, I need to go my package and a sub package, right? So this is a lot of extra work, right? And of course, programmers are really lazy. Actually, it looks like it works correctly, right? And we can use this, we can make a shortcut basically, right? So now this is going to be much basic. I import my package sub package utilities as SU, right? And now, right, I can skip all this extra work. I can do this, right? I can do SU, well, bad print. I can do sub add, for example, right? 100 300 something, and I'm gonna of course comment this out already so you can see this is not related anymore, right? So shortcuts, so SU is the alias for sub utilities, right? Including including folder. Yeah. Okay. Module. Right. Again, this is a module, right? So package, another sub package, right? Again, and then the module, right? And of course I import and of course this is a function, right? Right, and it works, of course, it works, right? So yeah, I could even, if I really want to go crazy, well, not really crazy, but I could go here. I only want to get this single function. I could do this, right? I could import a specific. I could import a specific function, right? Again, using this syntax, right? So again, but generally, again, you don't really need to do this too much, but again, so I can use it like again here, sub 200, 300, right? I'm gonna, again, of course, again, being just beware name collisions, right? Because if somebody else sub-add, right, again, that's why you have to be risky. So this is safe as long as there's nobody else using SU, and here of course you have to also be safe as long as nobody else is using sub-add, right? All right, and that's basically it, right? So how we make our own modules, right? But there's one little thing you have to be a little bit worried, right? Is if you are importing OS, like if you're importing something else, right? Well, the order how imports are working, right? Let's take a look, right? Let me show you how you would want to organize your code, right? We probably want to even here, right? Do something a serious normal program. It'll do this, right? Control Z. So I'll make a main function. Again, main is in Python. Main is just a name. It could be anything, right? In some function, in some programming languages, main is special function. Here is just a name, right? It really is just a name. So well, let's do this, right? You can see here. So, but how do we run it? Nothing will happen right now, right? Nothing happens, but so I'm going to add it here, right? So now I have nicely organized code. Right? If name is main, I'm going to run the main, right? Again, these are not related, right? This says, okay, this is run as a main. So this is so-called main guard, right? So again, my main application. Maybe you could have a setup or config function here on, right? For example, we could have a cleanup function. Thank you, AI. Very good. Right. So yeah, you can organize your this part here should be really short, right? Put the heavy stuff in the main, right? And of course, main also should be relatively short. You can put all the extra work in separate functions, right? And then your code also becomes quite nicely modular, right? And again, the advantage of this is that if anybody you have some function here in your code which somebody else wants to use it, they can import this main program and start using it, because the program, when imported, will not run, right? Everything running part happens here, right? This is your main entry point. The main entry point, right? Right? So, okay, but let's do something else. Let's run it. Yeah, it tells you my name is main, right? Of course, I will start looking. And now the question is, where will it look for programs? Well, this is going to be sys, right? This is going to be an error, because it's not defined. This is from the from standard library. We'll look at that separately after the lecture, in a live lecture. So now it works. So now notice something here. These are the maps on my computer, which shows where it will look for the packages, right? And notice, so this is the first place to look is the actual current day 11, or actually of course day 12 for you, folder. So this is an important point. If you name your module syspy or ospy or any of these taken names from standard library, it will be it could cause a problem, right? So your naming should be somewhat specific, right? Something which indicates, you know, it's your own project maybe, or, you know, don't use something list or something, or I don't know, or daytime, right? Don't call your, for example, your folder, your module daytime, for example, right? That would cause a problem. So no, okay, let's import my mod, right? And now, well, so now I can start working. So now this is normal work, right? And it will work, right? I'm starting work, right? Again, normal stuff, right? I can also check again. I can check for my system version info. Let's see what Python I'm using here. Probably 3.10. Yeah, it shows you Python 3.10.6 here in this case. You can see it actually matches this here, right? You probably have 3.11, right? But again, it matches 3.10 here in this particular case, right? So let's recap. What did we learn today? Well, so we learned that in Python, your own modules are basically files, right, in the same folder as yours. If you want to organize it, you can make subfolders, right, make it even closer, even subfolders, right? Like in this case, you had this my package subfolder, which holds more files, and even then a sub-package folder, which holds more py files, right? Again, py file basically considered as a module, and the package is basically a collection of modules, basically, right? So a way of organizing this. Then you might say, what's a library? Well, not really a library, we don't really have it here, but you can say it's even bigger. Standard library, like in Python, is a collection of packages, you could say, right? So what else? Yeah, and then we saw how to organize your code. You want to probably in your application, you want to use them in any serious application, you want to use a name guard, right? And you have a main entry point, right? And then you can start organizing. Of course, for smaller programs, this is a little bit of overkill, but not a bad practice in any case, right? It's just extra work, right? You're making quick script, maybe you don't want to do this, but for larger programs, you probably want to do this, right? So, what else? That's probably enough for now. And in our live session, we'll look at some of the standard library features. All right, thank you.